Hi class, this is the last lesson I'm going to have for you for today. This is the conclusion of the substitution, elimination, and graphing lesson. There are going to be times, especially in substitution and elimination, when you're working out a problem and all of a sudden your variables disappear. X's are gone and Y's are gone. So all you have is the constants left, or just the numbers. So if you get something like 5 equals 5, or you get 12 equals 12, or you get 7 equals 7, or a negative 5 equals negative 5, if you get a statement that is true, the left side and the right side are indeed equal to each other, if you get a true statement, then your answer is all reals, or all real numbers like that. You could write that for the symbol. Another thing that you could write on a test is you could write it is the exact same line. Let me prove to you that it is indeed the same line. Remember, what we're dealing with here is we're dealing with straight lines. Y equals mx plus b form, or ax plus by equals c standard form. We're dealing with lines here. So let's just take this for example. We have two lines, the first one being 2x plus 4y equals 7, and y equals a negative 1/2 x plus 7/4. This isn't on your notes, so just kind of sit back, relax, and enjoy as I prove to you this first statement about how if 5 equals 5, then you have an answer of all reals, or they are the exact same line. If I were to solve for this using the substitution method, I would say y is already by itself. Let's substitute that in for this y. So watch as I do that. 2x plus 4 times what y is. And y is now a negative 1/2 x plus 7/4. That equals 7. So now I'm going to solve for x first by distributing. So I get 2x plus 4 times a negative 1/2 x is a negative 2x. And then I have a positive 4 times a positive 7/4. These 4's cancel, so it would just be a positive 7. And that equals 7. So now simplifying the left side, 2x minus 2x, that makes 0 x's. Or I don't even have to write it down, and I get the answer 7 equals 7. So if I got that on a test, I would write down all real numbers, or I would write down they are the same line. The reason why you have infinitely many solutions is because one of them, let's just take this one for example, the y-intercept is at a positive 7/4, so that's almost 2, something like this. And then my slope is down 1 over 2, so something that looks like this probably. Right? And now this line, watch what happens if I put this one in slope-intercept form. Solving for y, I would first subtract the 2x to get onto this side. So 4y equals a negative 2x and a positive 7. And then I would divide by 4 to get y equals a negative 1/2 x plus 7/4. And class, that's the exact same one as this one, isn't it? So if I were to graph this, I would get a line that would go right over the top of it. So remember what we find when we substitute and eliminate and when we graph, we find an intersection point between two lines. Is there any intersection point between these two lines? There's no intersection point. I guess there's infinitely many intersection points because they lie right on top of each other. So if you ever get a true statement such as this one, 7 equals 7, or this one, 5 equals 5, or a negative 15 equals a negative 15. As long as you get a true statement, you can have one of these three answers. All reals, which this is the symbol for it, or the exact same line. Now, similarly, if you get something like 2 equals 5, which obviously is an untrue statement or a false statement, your answer is no solution. 2 equals 5, or if 15 equals 13, or a negative 5 equals 7. Any untrue statement or any false statement, you're going to put down no solution. Another word that you could put for that, instead of no solution, you could put they are parallel lines. A solution for a system of equations is an ordered pair. It's an intersection point. If two lines never ever intersect, such as parallel lines, then there is no solution. Let's take this one for example. Y equals 2/5 x minus 4, and y equals 2/5 x plus 3. In your mind right now, hopefully you're visualizing an xy coordinate plane, where on this one, you're seeing, well, the y-intercept is at a -4, and it's going to be a rise of 2 and a run of 5. So it's going to be a line that looks something like this, I suppose. Rise of 2, run of 5. This line has a y-intercept of 3, and this one has a rise of 2 and a run of 5. So the slope is the exact same. So these two lines, if I would have drew them straight, they would be better. But these two lines will never, ever, 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 ever intersect. They will go on for infinity, and they won't get any closer to each other, nor will they get any further away from each other, because they will stay that exact same distance away. They are parallel. So here's what would happen if you were to try to substitute or eliminate. Once again, we'll solve this by substitution. This y is already by itself, so we're going to substitute that in for this y. Okay? So we're putting this into here. So y, which now equals 2/5 x plus 3, that is in place of this. Now that equals this, 2/5 x minus 4. So now getting all my x's together, I might subtract 2/5 x right here. And I get 2/5 minus 2/5 is 0 x's, or just 0. So then on the left side, I have the 3. On the right side, 2/5 x minus 2/5 x, those are gone. All I have is the -4. Does a positive 3 equal a -4? Absolutely not. That is a false statement. And the reason for that is because obviously these two lines are parallel. They won't ever intersect. That intersection point is our solution, and if two lines never intersect, then our answer is no solution. So if you get a false statement, your answer is no solution or parallel lines. If you get a true statement, your answer is all reals, or else they are the same line. I hope that makes sense to you. If it does not, please come and ask me in class, because I really want to make sure that you understand that property. So there is lesson 3.2. Make sure you watch all 4 of those videos.